Right now, major tech companies are engaged in a massive capital expenditure boom, pouring trillions of dollars into building out artificial intelligence infrastructure. But there is a glaring paradox at the center of this spending spree. Nvidia already makes the best hardware in the world. So why are companies with virtually unlimited capital frantically spending billions of their own money to design and build custom silicon from scratch? Standard textbook economics relies on perfect competition. In that model, thousands of identical buyers and sellers interact, and no single player has the scale to control the price. The AI hardware landscape looks absolutely nothing like that. The AI market operates under a specific structure called industrial organization. Instead of thousands of competitors, the entire global market is ruled by an upstream monopoly, Nvidia, and a downstream oligopoly made up of a few giant cloud providers like Amazon, Google, and Microsoft. These dominant players do not react to market prices. They act as chess grandmasters, intentionally setting prices to extract the absolute maximum value from every transaction in the ecosystem. The current astronomical cost of renting AI compute is a deliberate economic trap, weaponized against the end consumer. To understand exactly how this trap works, we can build a simplified economic model. Assume producing a single unit of AI compute costs exactly $1. Nvidia acts as the first toll booth, stacking a massive upstream markup on top. Cloud giants act as a second toll booth, stacking their margin. The chip now costs $4.75. Economists call this specific compounding effect double marginalization. It is an economic inefficiency that occurs when two companies in the same supply chain both possess monopoly power and apply their own distinct markups to a single product. Because these two monopolies are entirely independent, they successfully stack their profit requirements on top of each other without coordinating. The immediate consequence is severe. AI compute becomes severely overpriced and artificially scarce for anyone trying to actually build software or conduct research. We can model exactly how this trap works. We will use a 4-stage economic simulation, where 1 GPU equals 1 unit of compute, and the base manufacturing cost is fixed at $1. This chart shows the baseline state of the market. The blue line represents the original market demand, the true amount of computing power that AI startups and researchers actually want to buy at a given price. Nvidia does not sell directly to those end consumers. They sell entirely to the intermediate layer, the cloud giants. Because cloud providers operate as an oligopoly, they require a profit cut. This mathematically rotates the demand curve downward, creating the green derived demand line. The difference between consumer willingness and what Nvidia sees is this gray margin wedge, representing the exact profit cut extracted. Nvidia is blind to the true market demand. They are forced to price their chips based on a shrunken market that has been artificially constrained by the profit requirements of the downstream oligopoly. This next chart shows how Nvidia calculates its wholesale price based on that shrunken derived demand. The blue line is the demand they see, and the red line is their $1 marginal cost, the baseline expense to produce one additional chip. To maximize profit, they use the dashed green line, marginal revenue. This curve tracks the exact amount of additional income Nvidia earns for every single new chip they sell. The mathematical peak of their profit occurs exactly where the marginal revenue curve intersects the $1 marginal cost line. Tracing straight up from that intersection to the derived demand curve gives us Nvidia's optimal wholesale price, $4 per unit. By holding the price at $4, Nvidia captures the massive light green area, securing a 75% gross profit margin on every chip. They actively choose to restrict the total volume of chips entering the market. Selling fewer chips at a massive markup yields higher total returns than maximizing market volume. This final chart combines both models to show the reality for the end user. The cloud providers are forced to treat Nvidia's $4 wholesale price as their own absolute minimum input cost, stacking their profit requirements directly on top of it. To extract margin, cloud providers further ration supply, creating the orange block, the second half of the double margin. This throttles market supply to 2.25 units. Startups bid the final consumer price up to $4.75. Economists call this severe inefficiency a deadweight loss. The consumer pays nearly 5 times the physical production cost, simply because two consecutive monopolies successfully stacked their margins. For cloud providers, the only way to lower input costs and capture market volume is tearing down Nvidia's toll booth through vertical integration, building the chips themselves. We see this in scenario 2 of the simulation, where Google produces its own tensor processing unit, or TPU, internally at the base $1 cost. With a major customer suddenly self-sufficient, Nvidia is forced to react. To prevent the remaining cloud providers from leaving, they cut their wholesale price down to $2.50. This immediate drop in input costs allows the entire downstream market to expand. The final consumer price falls to $3.25, and the total available supply increases to 3.75 units. Google makes this move entirely to improve its own profit margins. Yet, the strategic threat of an alternative forces a wholesale price drop that benefits the entire ecosystem, even the competitors still buying from Nvidia. If we advance the simulation to its endgame, we reach a state of total vertical integration, where all major cloud providers have shifted to their own custom silicon. At this stage, the middle margin layer vanishes. With internal costs sitting at $1, the cloud providers compete directly on volume.
As the equilibrium point moves from scenario 1 to scenario 4 along the demand curve, the price decreases while the quantity supplied increases. In other words, the final price is nearly cut in half, and the volume of chips released into the market doubles. Vertical integration is boosting consumer welfare and expanding the total economic surplus. By shifting value from upstream providers to downstream firms, it's creating a much healthier and larger AI industry pie. As a result, Nvidia's dominance is shrinking while Google takes an early lead. Although semiconductor profits decline, value is moving toward consumers, making the overall AI market far more sustainable.
Vertical integration systematically dismantles the pricing inefficiencies of the original supply chain. It forces the transfer of massive economic value away from the hardware manufacturers and directly into the hands of the consumers. The trillion-dollar tech giants are fighting this chip war strictly to protect their own profit margins. But the mathematical byproduct of their corporate self-interest is the democratization of AI compute. The final result of this competition will be the transition of AI computing resources from a scarce, expensive luxury into an abundant utility, like electricity.